The CleanRF Systems Oscilloscope Applications Demonstration. Note, when monitoring base energy on HF or VHF, an oscilloscope with a higher vertical bandwidth than the maximum frequency you will be monitoring must be selected to easily cover the entire radio spectrum and out-of-band artifacts when and if they develop. A list of recommended oscilloscopes for HF viewing is available on our applications page. First, we will begin using two detection sources referred here on out as XY mode. This method is used to feed both the horizontal channel 1 X and vertical channel 2 Y inputs of your oscilloscope. This simultaneously compares the output signal of the transmitter with that of the linear amplifier. With our Splatter view system connected to my oscilloscope as seen in figure 1A from our applications page, we are ready to do some initial adjustments. Seen here, the oscilloscope is being adjusted for vertical positioning. Now the oscilloscope is being adjusted for horizontal positioning. Next, with a continuous carrier established at the desired power level, we reference the oscilloscope's vertical channel 2 Y volts per division control to display for plus or minus 2 divisions vertically at the display grid as shown here. With the noted carrier power level shown on your inline watt meter and the oscilloscope displaying plus or minus 2 divisions on the display grid, we can accurately use the oscilloscope as a true PEP watt meter. More details on this can be found in the Application 3 on our Applications page. Now, anytime your modulated SSB or AM pattern extends to reach the vertical plus or minus 2 division mark, your peak envelope power will be exactly at the relative power you established with the inline watt meter during the continuous carrier. For this demonstration, we have calibrated a carrier of 400 watts peak envelope power. Next, move the focus dot to the far left side of your screen. At this time, while applying voice or data modulation, adjust your horizontal channel 1X volts per division control so that the trapezoidal pattern fills half of the screen horizontally. A one-page PDF describing the anatomy of a trapezoidal pattern may be viewed by clicking Figure 10A on the Applications page or by viewing the full product information sheets found on the Products page. Our oscilloscope pattern, as seen here, is testing for amplifier linearity. This condition will display a perfect straight-sided trapezoid as I modulate or during any voice or data transmissions. And as you can see, I am transmitting in a very linear fashion. If your amplifier has a non-linearity issue, the trapezoid's sides, opposite the point, will be flattened on the ends, or some other distortion of the trapezoid will be displayed with a noted lack of distinct straight symmetrical angles. Now, with our oscilloscope displaying our channel 2 vertical Y input only, the pattern shown here is a well-modulated SSB envelope, indicating that we are well controlled on peaks, not exceeding our plus or minus 2 divisions we calibrated earlier for the 400 watt peak power. Thanks to CleanRF Systems, monitoring our transmissions for purity and integrity is a cinch, and is as simple as connecting a few cables. Are you ready for CleanRF? The Splatter view from CleanRF Systems.